Okay, seems all right. Okay. Hey, everybody out there. Good morning, good afternoon, or good evening, wherever you are. It is good afternoon here. So, yeah, yesterday was interesting. It was a bit of a stab in the dark, or whatever you say. I found a video as I was researching about how JPEG XS works, you know, who's working on it, what existing software there is out there. And I found this very useful video by somebody working at AWS in one of the, in like some production division of it or something like that. So what I thought we'd do is basically just run through the video. It's about 20 minutes long. And they go through just a little bit more detail of how JPEG XS can be transported with RTP. So we were able to implement the JPEG XS RTP packet header, marshalling and unmarshalling, but we don't know much more than that. Plus there was a bunch of like, you know, things about how it kind of, you know, how to actually transport a stream that are explained well in this video. So let's just get cracking. I figured basically we'll just watch the video, and then if there's bits where we want to write code, then we will. And then if there's not, then, well, we just listen and try and understand. It's not a super long video, as I said. So I guess this won't be a super long stream because I'm going to be traveling up to the tropical Australia to take care of my grandmother for the next week. So I'll bring my laptop and stream, but you can say goodbye to the nice audio quality and camera, and not that they're great, but yeah, going to be some shitty shitty camera and shitty microphone. Anyway, let's watch this and just make sure that I might have to work out a way to do the audio properly with the speakers and stuff, but yeah, anyway, let's just give this a go.
On web services. I'm a principal solutions architect specializing in broadcast. Some of you may know me from my 20 years in the broadcast industry, first at PBS and then later at the Fox network, and more recently at Disney. About a year and a half ago, I had a great opportunity to move into AWS, into the BDSI Media and Entertainment Group. It's super exciting. We're doing lots of neat stuff, including JPEG XS. So what is JPEG XS? JPEG XS is a low complexity and low latency, high quality codec. Now JPEG is the joint working group of the International Standardization Organization, ISO, and the International Electrotechnical Commission, IEC. JPEG XS is standardized as 21122. It's neither a JPEG nor that you use on the internet every day with discrete cosine transforms. It's also not JPEG 2000, which is a wavelet-based codec, which is often used in digital cinema and has previously been used for live broadcast contribution. XS means either extra speed or extra small. It is a wavelet-based codec, like JPEG 2000. However, unlike JPEG 2000, which generally requires an ASIC to be encoded or decoded in real time, JPEG XS is a very low complexity codec. You can do 4K 60p encodes and decodes on an Intel i7 in real time. And that's what makes it kind of exciting. We can break away from ASICs, and we can have this running on CPUs, either on premises or in the cloud. There is a royalty required for use of JPEG XS. However, the intellectual property of the licensing pool is fairly well understood, unlike a lot of other distribution codecs out there. And I should also mention there is no dash in the name JPEG XS. So if you ever see a dash in JPEG XS, just cross it right out. It's just JPEG space XS. So this talk is about wrapping JPEG XS and RTP. It's a bit of a technical talk, but I think you'll get a lot out of it if you're interested in how JPEG XS is actually moved in RTP over IP. And there are 4 key defining documents that you're going to have to read, unfortunately. in order to encode, in order to pack JPEG XS into RTP packets. The first is ISO IEC 21122-3, which specifies metadata boxes, which will be used in the transport. IETF RFC 9134 is the RTP payload for JPEG XS from the IETF. SMPTE ST 2110-22 is how constant bitrate compressed video works within SMPTE 2110 infrastructure. VSF TR08, that's the Video Services Forum, for those who don't know, it has JPEG XS constraints for television signal interoperability to make sure that everybody is kind of moving in the same direction. Some vocabulary you will need to use as you read these standards documents include ADU, which is an application data unit. And that's spread across one or more packetization units. And in code stream packetization mode, a packetization unit is a JPEG XS picture segment. It's going to be made up of your video support box, a color support box, and also the JPEG XS code stream of one field or one frame. Now, VSF TR08 only allows for code stream packetization mode. So I'm going to skip the slice packetization mode, which is also defined in 9134.
There we go. There we go. Hold up. That was important. Right, so what they're saying is that, let's go back.
TR08 only allows for code stream packetization mode. So I'm going to skip the slice packetization mode, which is also defined.
VSF TR08 skips.
A color support box, application data unit. VSF TR08, that's the Video Services Forum, for those who don't know, it has JPEG XS constraints for television signal interoperability to make sure that everybody is kind of moving in the same direction.
Okay, so what they're saying is that if we go to RFC 9134, all right. Yeah, here we go. So what they were saying is that this is the only, I mean, I think what they're saying is that, and at least for us, we'll only implement this way of putting it into RTP. So if we look at, so in our packet header, this packet mode is always going to be code stream. And that means that the slice here we go. In the case of this counter resets whenever the packet in this slice is. Yeah, so basically it just simplifies it for us because, you know, for example, some of these counters are only, you know, for example, the frame. Like, I think it means that the frame directly matches up with the code streams. And compressed image frame. Oh no, sorry, a compressed image formatted according to JPEG XS Part 1, a sequence of bytes. So what's a slice? Wavelet coefficients. Yeah, right. Okay, so I guess this is saying that these are just like, and yeah, okay, is it not? well, there we go. So that for sure, right? So we're going to have a marker. Yeah, that's a 2-byte marker, I remember, the code stream. And then there's the starter, and then there's the end. So that's going to be, to me, that feels easier. Especially with slice packetization mode. Yeah, I mean, that for one thing, yeah. Okay, let's get going.
Some vocabulary you will need to use as you read these.
As we read that. Okay, here we go.
Code stream packetization mode. So I'm going to skip the slice packetization mode, which is also defined in 9134. So in RFC 9134, it's got an RTP header. There's no big surprises. This is much like any other RTP payload RTP header. Version, padding, extensions,
so this
CSRC count, sequence number, synchronization source, contributing source identifiers, or just like RFC 3550 RTP. The marker bit indicates the last field or last packet of a field or frame, and the timestamp is 90 kilohertz. Again, no big surprises if you've been doing other RTP payloads. The RFC 9134 JPEG XS payload header is something new. It includes T, a bit for transmission mode. 1 is to be sequential transmission, and 0 is maybe out of order. And I don't know why you'd want to send your RTP packets out of order, but you've got an option. K is a packetization mode. We really had to work for find the bit identifiers. 0 is code stream mode, and 1 is slice mode. As you all know, VSF TR08 only defines code stream packetization mode, so that'll be a 0 in most of these applications. L is the last packet of a packetization unit, and in code stream mode, the end of a field or frame, which would also be the same as the marker bit of the RTP header. I is interlaced information. 00 means it's...
Let's add that to the documentation. So we want to set this to the, and this is, yeah, when this is true, or when, yeah. Something like that. I wonder if I can do a like a doc reference here, so with the corresponding marker field of the RTP. Yeah, of the RTP, yeah. No, that's fine. Okay.
Progressive 10 is the first field, and 11 is the second field. F is the frame counter modulo 32, so you can watch the frames go up. Slice and extended packet counter resets when the packet counter resets and increments by 1 every time the packet counter overruns. So it's kind of a way of extending the packet counter. And of course, P, the packet counter, which counts the packets in the packetization unit, which for code stream mode, it's the JPEG XS picture segment. It's modulo 2048.
This I didn't quite understand, the packet number within, see this is, yeah, we need to get this.
Which counts the packets in the packetization unit, which for code stream mode, it's the JPEG XS picture segment. It's modulo 20.
Now the other thing I want to do actually is, So the packet counter is the, I don't quite understand what this is. We might come back to it.
Then we're going to come to box picture segment. It's modulo 2048.
I think that's that.
Then we're going to come to boxes. Now, in the upper right-hand side are some of my favorite boxes.
So what this means for us is that we've got let's say I sketched this out. Where did this go? Sorry, let me get back to this. So draft, yeah, here we go. Yeah, okay. So it's going to look like this, I think. Yeah, so every kind of like payload is going to have a header. So this is actually the payload header. And then we're going to have the packetization unit. And in a packetization unit, shit name, might come up with a new name, but anyway, yeah, we're going to have this like some metadata. And this is what they're talking about. These boxes. So if we, now this, of course, that, yeah, I think there's actually a diagram. Yeah, this one, I think. Code stream packetization and progressive video. Yep. Yeah. So this code stream is like, this is the real, like the actual, you know, this is the actual frame. So you could, in a similar like motion JPEG, which is literally just video with like normal JPEGs that we have like in a, you know, like you have in your browser or whatever. You know, imagine this is just like the actual JPEG file. So a JPEG file actually just consists of this, I'm pretty sure. So it has like a marker byte that tells you, hey, like this is the beginning of the file, and then it has all the metadata, and then blah, blah, blah. This thing is for like the metadata, which, well, I know this is only in RTP. Yeah, but you can have it in the, I think you can have this in the header of the actual JPEG XS file as well. But yeah, let's just keep sort of reading into it.
Our customer, Amazon.com. Unfortunately, we're going to be talking about ISO IEC 21122-3 boxes. Now, these metadata boxes are derived from atoms you may find in ISO BMFF QuickTime, but actually, no, these are specifically defined for JPEG XS. They're not exactly the same thing. A box has LBox, which is a 4-byte length field. It has TBox, which is a 4-byte
Hello to all transmitters and receivers.
And that's either going to be your JPVS for your JPEG XS video support box, or COLR for your color specification box.
Okay.
XL box is an 8-byte extended length field if the L box equals 1. So if you need a longer box, you can use that. And D box are the actual contents of the metadata box. So let's put some of these boxes to use. If you've got
Here we go.
your JPEG XS and RTP, the first packet you'll receive will have a video support box, a color specification box, and the first part of the JPEG XS code stream. The next packet will have the next part of the code stream, the next part of the code stream, until you reach the end of the field or the frame. The video support box is actually not just a box, it's a super box. It's a box that contains other boxes, which contains video information such as frame rate, field coding, time code, and the profile and level of JPEG XS. The color specification box is just a box. It contains color primaries, transfer characteristics, whether it's full range or not, the color information. So let's do a quick deep dive on this video support box. It's got a number of mandatory subboxes. So you've got to have the JPVI, the JPEG XS video information box.
What the fuck is this box thing? Just box. It's definitely not a field. It's called a box. Oh, hey, here we go. All right. So this. Okay, hold up. You know what I'm going to do is I'm going to just. I'm going to put this. Okay, so what we're going to do is we're going to look at our, looks like, see, so these are fields in an actual box. So we need to, what I want to do is go back to the boxes. So that's 845. Okay, so let's look back. Oh, shit. Yeah, this.
So let's put some of these boxes. One. So if you need a longer box, you can use that.
So it's going to look something like this. You have the length is a UN32, type. Also, is that 4 bytes? And 8-byte extended length field if L box is 1. And then you have the data, which is just going to be like something like that. I don't know. Oh no, that's, yeah. This is like the intermediate. Yeah. So you're gonna, so video box really, like inside of it is gonna have this stuff. So you could almost do like a, you know, it's like embeds a box in it, something like that. And then, yeah, like that. Or just even just box.
And dbox are the actual contents of the metadata box.
So why is this? What does this mean? Like 7? Why is it 7673 or? Oh, those are the bytes. Okay. No? Right? Yeah, because that's 1, 2, 3, 4 bytes. Okay. So what we're going to do here then is we're going to go box, yeah, I don't know. I mean, anyway, let's just do box type is OX6A70 7673. Hold on, is that literally ASCII for JPVS? Is it? Cool. Oh, there it is. Okay. And, you know, now we don't even need, like the type is actually just a, right. We'll keep working on that. That is good.
So let's put some of these boxes to use. If you've got your JPEG XS and RTP, the first packet you'll receive will have a video support box, a color specification box, and the first part of the JPEG XS code stream. The next packet will have the next part of the code stream, the next part of the code stream, until you reach the end of the field or the frame.
Oh, wait, I can speak.
The video support box is actually not just a box, it's a super box. It's a box that contains other boxes, which contains video information, such as frame rate, field coding, time code, and the profile and level of JPEG XS. The color specification box is just a box. It contains color primaries, transfer characteristics, whether it's full range
I know.
or not. The color information.
Some of these names are very dubious, you know.
So let's do a quick...
Like video box. What about like just video info? Like you have to or like these things. It's like packetization unit. It's like, what about packet? I don't know. Like, or like the, you know, like color. Just like color field. The color field tells you these things. Like, no, it's a box.
Deep dive on this video support box. It's got a number of mandatory sub-boxes. So you've got to have the JPVI, the JPEG XS video information box. That includes BRAT, the maximum bit rate, FRAT, the frame rate, which also includes interlace mode, and also numerator and denominator for those.
Okay. So it contains this, and then there's another box type. So box type video info, and that's actually JPVI. JXPL. All right. So this is actually video support. I'm going to do this, but yeah, we'll work it out.
Countries that use fractional frame rates. SCAR is the sample characteristics, which includes the bit depth and the sampling. And T code is a time code, not SMPTE time code, but it's hours, minutes, seconds, frames time code. The JXPL is the JPEG XS profile and level box. And this includes PPIG, the profile, and PLEV, the level of the JPEG XS that you're using. Don't you love these names? Engineers. The optional sub-boxes include BMDM, the buffer model description box. And this
standards writers or something, I don't know.
The TMBD is going to contain your buffer model, which is defined in ISO IEC 21122-2. The buffer model can either be one with a limited transmission latency, or you can use a buffer model that has the full use of the decoder smoothing buffer, which will give you a variable transmission latency.
Hold on. So these are optional fields. So
buffer model description.
Mandatory. Okay, there we go. Okay, so these are the, yeah, right. So really, like, yeah. Okay, so that's a good diagram. So really, I think we're going to have like this, right? This is the max. Yeah, let's just start putting it here. Is a UNT32. The frame rate is a UNT32. Sample characteristics, bit depth, and sampling. Not sure what that is. Let's do the time code. Hours. 32 bits. Is that... Maybe this is a 32-bit field because it's got the interlace mode, numerator, denominator. Oh, yeah, okay, we'll have a look at that in a bit, but let's go...
And level box, and this includes PPIG,
back a bit more.
Time code, but it's hours, minutes, seconds, frames time code.
Would that be 32 bits? Like, wait, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so this actually contains, okay, it does that anyway. So those 32 bits are actually like, yeah, you got, yeah. So you've got 1 byte for hours, 1 byte for minute. And then, yeah, so really it's a time code kind of looks like this. You'd have hours, 8 minutes, and then you'd have seconds and frames, but that would, you know, you'd need to, so those are, no, wait, well, 8, 16, 24, oh no, yeah, it's all just, that's really what it is. Why would they, like, so many different time codes? You know what I mean? Like, because it's like you've got time codes all the way through, like all the way through the stack. Is it? This one is not even, like, this isn't even that precise. It's only frames. Anyway. And then, you know, this, I mean, like, you'd almost just, I mean, why encode it like that? Like, why not just have, like, I don't know, like, you could almost just, like, put that into seconds or something. I don't know, like, why have hours, minutes, seconds? So why not just do seconds? I don't know, like, it just seems very, I don't know, it just seems funny. It's like, seems like a weird thing. It's like, am I really, it's like using, I mean, like, in a sense, like, it's literally just like a string, like a time code string. Is that really useful? I don't know. It's just, that's something at like such a low level of this of the whole thing. You've got a time code string, like what? What? In every single frame, right? Like, oh no. Yeah, this is it in every single frame. In every frame, you've got this string. Bizarre. Of all the ways to encode time. What if there's something more to this? Anyway, but I mean, it's just interesting just because, like, I don't know. Yeah. Anyway.
The JXPL is the JPEG XS profile and level box. And this includes ppig, the profile, and plev, the level.
All right. So video support has these fields in it. It has to have bitrate, frame rate, sample characteristics, time code. I mean, time 1. I'm just kind of just drafting out stuff here. And then I mean, yeah, would you use a struct or just an array of like 1, 2, 3, 4 bytes? I don't know. I think struct is clearer. What the hell? So not useful. Ugh.
Of the JPEG XS that you're using.
Profile level is
Don't you love these
profile.
things? Engineers. The optional subboxes include BMDM, the buffer model description box, and this uses the TMBD. The TMBD is going to contain your buffer model, which is defined in ISO IEC 21122-2. The buffer model can either be one with a limited transmission latency, or you can use a buffer model that has the full use of the decoder smoothing buffer, which will give you a variable transmission latency. And this will also contain the number of coefficient groups for both horizontal and vertical blanking periods if they're required. Daemon is the mastering display metadata box. And for those of you HDR fans out there, it's going to have your SMPTE 2086 metadata, including your maximum content light level, your maximum frame average light level, all of that as per CTA 861.g. JPTP is the JPEG XS video transport parameter box, and these are various suggestions to the decoder, such as the number of slices that you might want to assign to processing units, the number of parallel decoding units, and also the size of the packet reordering buffer. This brings us to the color specification box. The color specification box, COLR, some of the fields include MEF. That's the method, but the truth is only one method is defined. The coding independent code points of REC-ITH.273. So it'll be 5 to indicate that. PREC is a precedence, but it's currently undefined, so it's going to be 0. And
wait, what? What's going on here? Oh, there we go. There's our math.
In MEFDAT, which is the method data for the coding independent code points, you've got CP, that's your color primaries, TC, your transfer characteristics,
THC,
MC, the matrix coefficients, and V is going to be a video full range flag. It's going to be 1 if it's full range. Okay, if you look through VSFTR8, they're going to
too good.
Code points.
Oh. Might need a bit of that myself. I mean, what the meth. THC, MDMA box. Need that as well. Need the PCP.
In MEFDAT, which is the method data for the coding independent code points, you've got
okay, so this is our color spec. Method. Like, I mean, why give it an, I don't quite get it. Like, why name it? I mean, it's
CP.
The name is method, not meth. It doesn't.
in MEFDAT, which is the method data for the coding independent code points, you've got CP.
So let me just go back because he was talking about it, but I forgot to change the
So it'll
slide.
be 5 to indicate that. Truth is only one method is defined. The coding independent code points of REC-ITH.273. So it'll be 5 to indicate that. Prec is a precedence, but it's currently undefined, so it's going to be 0.
Okay, hold on. So it's saying that there's only one method, and that's 5. Okay, so yeah, I mean, precedence undefined should be 0. Okay. Okay, let's listen again what he's saying here.
You've got CP, that's your color primaries. Prec is a precedence, but it's currently undefined, so it's going to be 0. And APPR is a color space approximation, again undefined right now, currently 0. In methodat, which is the method data for the coding independent code points, you've got CP, that's your color primaries, TC, your transfer characteristics, MC, the matrix coefficients, and V is going to be a video full range flag. It's going to be 1 if it's full range.
For this, yeah, right. Okay, so here's our data structure. So we've got method, precedence, approximation, color primaries, transfer characteristics, matrix coefficients. Yeah, okay, and that's going to call to the method data. So we could probably just put it, I mean, again, like, yeah, we can work all this out, but say color primaries. I hate writing it in the American spelling, but I have to do it. Yeah. Oh, yeah. Like, and I'm sorry. It's I think, yeah, I don't know. I don't think I only hate it in the sense that my fingers want to do the spelling that I'm used to. All right. Let's read about this V.
And V is going to be a video full range flag. It's going to be 1 if it's full range. Okay, if you look through VSFTR8, they're going to have a list of common color specification boxes, including SDR and your PQ and your HLG HDRs, each with the different color primary codes, transfer characteristics, matrix coefficients, and video full range flag.
Yeah, I got it.
And now
okay.
let's get to that JPEG XS code stream.
So this is actually
there are a couple of different elements of the JPEG XS code stream. These include markers.
There's a few like
so these identify structural parts of the code stream.
So it's almost like
there are marker segments. So these are
sorry. So put like
some video full range.
Wait. Yeah, like you'd almost you always try and save these things or something, like store them as constants or something. I don't know how, but yeah. Yeah, okay.
And
maybe there's actually, sorry, I just realized maybe there's something actually in the, I need to look at the image package in the Go standard library and just see where some of this stuff fits in, because it does somehow a little bit. Because there's, you know, there's like types for color space and stuff like that. Yeah. But this is stuff that I've not got into this type of stuff before, so I'm like, oh, what is this? What I would like to do, maybe have a look at this type. Interesting. Yeah. Anyway, okay, cool. That's all right. Well, let's do this, unit 16, and then I know it says it's a unit 8, but it's something 0 or 1, right? I don't
matrix
know.
coefficients
Okay,
and video full range flag. And now let's get to that JPEG XS code stream. There are a couple of different elements of the JPEG XS code stream. These include markers. So these identify structural parts of the code stream. There are marker segments. So these are markers which are followed by a length field and data parameters. There's entropy coded data, which is wavelet coefficients, which have already been entropy coded. Also, you should know what a precinct is. Precinct is entropy coded data of wavelet coefficients contributing to a spatial region of the image. So you see here we've got an image on the left, and then we're so the code stream syntax goes like this.
Here we go. So that's actually what's going to be in, yeah, here we go, here, this stuff. Yeah, and that's, Now for us though, we could just have a slice of bytes, because maybe at the end here, you know, we'd have the, you know, the end. But I mean, we don't have to store that in our structure. It's only relevant for the actual, yeah, when we're putting it into the, you know, putting it into bytes. So, yeah.
The first thing is start of code stream, or SOC. JPEG XS and AWS Elemental Media Connect. So in VSF TR08, there are a bunch of constraints on JPEG XS. First, you're using the code stream packetization mode. There's going to be a JPEG XS profile, high 444.12, and that's the limitation there. Yeah, that's the only profile allowed. There are 5 horizontal and 2 vertical wavelet transforms. So there's a limitation on what you can do with JPEG XS. You can only use the uniform quantizer. There is a limit on the number of bits per pixel allowed in terms of the compression. So 4 bits per pixel is the minimum amount of compression, and 1.5 bits per pixel is the maximum amount of compression. The number of bytes of the payload data has to be a multiple of 8 bytes. Senders and receivers have to support certain configurations defined in the document. And these configurations are combinations of a conformance level and a capability set. These include various restrictions on the audio and video, and the capability sets have different use cases. One is intra-facility, one is inter-facility, and there also is an intra-campus IPMX capability set defined. So it should be importantly noted that RFC 9134 took 3.5 years to develop, and during that time, people wanted to get their systems out there. So there are a bunch of implementations of JPEG XS and RTP which may use different versions of the Internet draft. We've seen some -0s and some -3s of the Internet draft, which were, of course, the Internet drafts came out before the RFC was finalized. So just make sure you're taking a look at your RTP packets and that you understand whether it's the RFC or when it's one of these pre-RFC Internet drafts in terms of the format. And yeah, thank you Intupix, who have made RTP Wireshark dissectors available for JPEG XS, available for free from their website. And this is really handy if you're trying to go into the RTP packets and really diagnose exactly what's going on in there. So people ask me, JPEG XS, is it interoperable? And you know, we had that question ourselves. So we worked together with the Amazon Studios, who hosted a JPEG XS interop in the Los Angeles area at the end of March, beginning of April. We had 11 different vendors show up. We were able to carry out over 200 different interoperation tests between these vendors. Basically, everybody sat in a room, and everybody hooked in to a big 10 gigabit Ethernet switch in the middle. We had encoders, we had decoders, we had multi-viewers. We even had a camera that did JPEG XS. We did not only on-premises tests through that Ethernet switch, but we even sent out JPEG XS over Amazon Studios Direct Connect into AWS Cloud, into AWS Elemental Media Connect. So we were showing it going on-prem and to the cloud, and back again as well. We were doing interlaced HD, progressive HD, and UHD formats. You know, you can read the vendors who showed up there. We put everybody up in a big multi-view, and it was very successful. There are 1 or 2 issues we found, but for the most part, I can say JPEG XS seems to be very highly interoperable. This was something Gareth Sylvester wanted me to put in here about NMOS. People ask, what about discovery and control for JPEG XS? NMOS is the registration, discovery, and connection management layer for most SMPTE ST2110 systems.
Oh, no, that's different. That's beyond this. So yeah, it's actually kind of interesting because what's happening is that, well, the way I've seen it described is a lot of, let's put it this way. You know, we've got VoIP phones, right? Like any sort of, you know, any phone calls that you make from your regular phone, wherever mine is, or like desk phones, that's all packetized now. So it's all, you know, using like SIP and RTP. But that hasn't happened yet for video. And one of the reasons I think is that there hasn't been a good codec for it yet. And they're saying that this is going to be like VoIP, but VoIP as in like video over IP, because that just hasn't happened yet. But is this going to be it? Yeah, probably. It's going to happen at some point, because, you know, everybody's got a shitload of IP equipment, like switches and routers and everything. Everybody's got loads of cables. But the difference is that, you know, a lot of these big shows, like this is the League of Legends, right? Like this was the first event, I think the first like big sort of, you know, the world first to use JPEG XS compression for a transatlantic remote production. Yeah, right. So from Iceland, they were sending JPEG XS over IP to, where did they send it to? Transatlantic. So I guess, wait, from Reykjavik? So from Iceland to Paris in France? Yeah, right. Because the main issue is when you look into it is the JPEG. Sorry, hold on. Like raw video is huge. Like, you know, like just for regular. Yeah, here we go. Yeah, like regular HD is. Yeah. And then to send this around, you know, over distance is, you know, very difficult. And to have it low latency, yeah, that also doesn't really exist yet. So there was a thing, let me just try and find it. Yeah, this is it. So the latency for a lot of these things is, you know, like way too high. Even though the bandwidth is low. So we hear a lot about these things, you know, HEVC, AV1, VP9, all that sort of thing. But that's only for, you know, that's like the final end of the chain. But for live stuff, yeah, like I think this is. So there's another one here that talks about. Oh, here we go. What? Yeah, this is it. Yeah. So, yeah, you need like 10 gigabit infrastructure just for uncompressed HD video, low latency, which is, yeah. Oh, wow. Interesting. That's crazy. Interesting. Yeah, but it's an interesting way of talking about it. So what they talk about is like how, you know, if you want to do like start doing 4K, then yeah, all this sort of thing. It's like, oh, okay. So the sell, I guess, is the sell that they're trying to push with this thing is that rather than buying a whole bunch of new equipment, can you use the cables that you've already laid? So I guess what were they saying? They were saying that like the cabling that you need, like, you know, you're only going to need Cat5e cable, which is, you know, pretty shit, right? So it's like your Ethernet cable that you get from like a router from the shops or something. Kind of interesting. It's interesting to see what happens. Yeah. But this is really interesting on GPU 1440p. Super interesting. Yeah, there you go. Yeah, this one, yeah, I guess the idea here, I think, is that they're doing, they're going for like the low latency on commodity hardware. Is that the idea? I know there's a bunch of cameras that just can do, you know, like HEVC, just, you know, just like you press record and it, bang, it just starts writing HEVC. So that's about, you know, yeah. Is that on the, was that over the network as well? Oh, on the GPU. Super interesting. What is this? Yeah, that's cool. So then, so the end-to-end latency is like, yeah, that's awesome. And then, so if you, oh yeah, oh, one frame, yeah, that's nothing, yeah. And then so from there, so that's, so hold on, wait, is this, so should I go to select, yeah, interesting. I don't know what this thing is. Is this like some software or something? I don't quite understand what this is. Like, is this a share some graph? So 50 megabit, 50 not sure about other sections are going to show. Yeah. Ah, yeah, gotcha. Okay. Oh, here we go. Ah. Yeah, cool. Okay, let me save that, and then let's hop back into the. Yeah, because what was that other diagram they showed about the? Yeah, interesting. Okay, yeah, as I say, let's hop back into this thing. So yeah, and then okay, so that's the color spec done. So is that the color support? A couple of different things here. Specification box, okay. Oh, is this the color spec? Yeah, okay. So color spec is color support. Okay, so let's. CS. Oh, so this. I don't know where I got color support from then. No such thing. Yeah, nice. Okay, cool. Color specification box. Okay, so that's color spec and video support. Cool. Alrighty, so let's keep that there. Let's have a look at this. So we've got here the color. So that's color spec. And this is actually the code stream. So that's what it looks like more. And then the code stream, there we go. So this is where we would get, so the first byte of, or the first 2 bytes of this would have our, the start marker, and then have all the other stuff. Now, what we could do here is this, right? As a very basic shit implementation, we could just go, okay, let's go for the start marker. Let's find like a length in here somewhere. And then eventually we'll just try and find the end of code stream marker. And then bang, we've got our, our actual code stream. Now we don't know what's in there, but we've got the beginning and the end and we know how long it is in the middle. Now that means that we can do this. Because we'll know the length and we know the size that we want to break these up into. So the most common size is going to be, we did the numbers yesterday, was like 13, so 1,384 bytes. This is based on the network MTU. So we're going to have something like a function that looks like this that, like returns a bunch of these. Now I can see how we can actually get this thing. Yeah, this is, fuck, I cannot believe it. Just little by little, right? Like it's just these little things. So it's somebody said to me, they would always say to me, oh, how do you eat an elephant? It's like, what the hell are you talking about, dude? How do you eat an elephant? This is impossible. You get, no, 1 bite at a time. Like, oh, okay, yeah, that kind of makes sense. Yeah, that's it. Yeah, you got it. Yeah, beat me to it, because I know you said that before I actually said it. Yeah. Good old latency. Yeah, no, 100%. So it's just these little things, right? But this actually, yeah, because we're going to have the video support. All right, so let's say we've got this. Yeah, we're going to have, so maybe not even that, right? Anyway. There's going to be some optional fields in here, so yeah. But we can get that from, because each of these is actually going to have an embedded, each of these is going to have these fields, length and the type. So, yeah. And then we're going to have the, now of course we could break this out into its own struct, but yeah. So yeah, we could definitely get the video support and the color spec out, because we know these are going to be, like, this is always going to be 4 bytes. Well, it's always going to be 5 bytes because we've got the box itself contains, oh no, so length you went 32. Okay, yeah, so anyway. That's always going to be 4 bytes as well. So this is, so for example, so we know, like, let's look at these things, right? So we could actually do this. We get that is always going to be, so like this. So the video info is going to be, what's the size of this? 4, that's 8 bytes. So 8, 12, 16, 32. Yeah. Am I counting that right? Yeah, right. So then, yeah, it's do something like that. And then same with this, we're going to have here box. Eight, 10, 12 bytes, and then maybe some other stuff. So we could go, like greater than or equal to 12 bytes. And this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 18. And then that. So in here, yeah. So in this function, we're going to have to, and then in here, we'll create a header, because we're going to split this thing up, and then we're going to have to increment it as we go. So this function, you know, might be a bit, you know, hairy, but that's okay. Like I think it'll be pretty boring because we're just going to be counting and just incrementing stuff all the time. So it shouldn't be too hard. And then we'll just have some checks like, oh, if it overflows, you know, like if it goes past the uint16, then we have to increment the other counter in the header. So as we go, we'll just keep updating the header, and so slotting headers in and then just jamming the code stream in because we don't really care what it is. Yeah. And yeah, and then we're kind of a little bit further along in the whole thing. That's pretty cool. Let's try and make sure I got this right. So we got the... Yeah. So we're going to have like a function that decodes boxes. So perhaps a box really, yeah. Right? Maybe it's going to look like this. So this is a box. Yeah, this thing, yeah. This is this stuff, so we're going to have a 4-byte length field, yeah, so we just try and... I think we can just do this in one hit, yeah. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wait, that's 1, 2, 3, 4, 5, 6, 7. How did they describe this again? This is the method. This is the actual thing. So this is going to be the color. Yes, this is color. what's this? This what do they call this again? Oh, it's not, yeah. Okay. Just an idea. Because then we can have a, you know, at least then we can have like some functions that return boxes, which looks like we're going to need because this, there's going to be optional, you know, fields or boxes. Then we could even have like a, you know, like this. We could just have a, you know, like, you know, a mystery box. Yeah? You know what the mystery box is? It's that. Okay? And you just like, oh, maybe a mystery box is a, you know, maybe we could store the type of it. So it could actually just be like this. And then we just say, okay, well, you know what I mean? Then we could just have like the mystery box. Would return the length. Would return the, you know, line of, yeah. I can't remember whether, I always forget whether the length of a string returns how many runes there are or how many bytes they are, but let's just write this for now, just for drafting stuff. And then just returns itself. Yeah. So it's just the unknown box. Because the one that we don't know or care about. But we will still be able to... Oh shit, no, so whoa, what am I talking about? No, this is this. We do need this. Yeah, so the mystery box is going to contain it's that minus you know, minus the type and the length. So in here it's going to be, yeah, right. So we're going to have the length and the type and then whatever. So it'll be the, so 8. And then this is going to be like, we're going to have to turn, it's pretty easy. So we know we're going to have to return a slice. So from 0, 1, 3 to 7. Right, because we've got, yeah. And this we could even just get the, I mean, there we could actually just do the slice again, right? So there, like that. And then, I mean, you know, at first all of these can be, I think everything could be a mystery box. Yeah. But anyway, yeah. Reminds me of that Simpsons quote, you know, it's like, oh no, I can't show Simpsons on here. It'll do something weird, copyright or whatever. But yeah, it's like, would you, what's that Simpsons one about the lawyers? It's like, yeah, anyway. Yeah, I don't deal with that. But for transporting, I think this is pretty much all we need. Oh. Yeah, that seems... Yum. Wish I could test the elephant theory on something. I've got no food here, nothing. Got a cold cup of tea, that's what I've got. Shit, it's dark. Hold up. And I just realized I got my head. Oh, Jesus, it's better. These headphones cut out so much noise. Well, they're not noise cancelling. They're just like ear monitors, you know. So they just like plug your ears. Hold up. All right. Okay, look, that's yeah. I think that's gonna work. We're gonna have to, yeah, we'll probably pull these out. So, and then because then we can implement the yeah, so that we can implement these methods to have them as boxes or something, maybe, but we might not even need that. I don't know. Yeah, probably won't need. Anyway, yeah, we'll see. So I don't know what the order of things needs to be in and all that stuff. Yeah. But, and I don't know how you know that you've got, like, how do you know that you've hit the code stream? Like, say you get the videos. Oh, no, because we know, because it has to, sorry. Yeah, so like we know that it has to have the, so let me look at, yeah, see, we don't know whether those boxes are going to be there. So, but I think we will know because the length field here will actually tell you what's in there. Because then, and then each of these will have a length. So you'll just read through the lengths and say, okay, we keep going. Oh, you know, do we have any bytes left? Oh yeah, okay, that means that we need to decode, you know, this, you know, the video support or whatever those other fucking things are. These things, buffer model, master display, blah, blah, blah. And then we know we have to do the, so in our, where's our actual, yeah, this thing. And then we have the code stream. And we know that the first byte has to be the start marker, and then we know the final byte has to be the end marker. And we can probably reach into the actual JPEG XS like frame, and there's a there's a header in there which gives us the length. And I think from then on, I think, well, actually, I don't know. We'll have to look at that, because the uint16 is probably the length of the header itself, not the actual. We'll learn about that later. So look, that's awesome. I can't believe we actually got some of that. So what I'll do is I'm gonna cut it there, because yeah, like that's, at least I'll cut it on YouTube, but then if anybody's interested in watching more, we'll yeah, hop onto Twitch, because that's just where the casual stuff happens. So yeah, that was a good session. I'll look at it one more time. Sorry. Doing JXS. Yeah, really, it's this stuff, isn't it? Let's put this up. There. Let's do a new file. There. So the box, that's the first thing. And then we do some boxes. Yeah, I'm happy with that. And then the actual JPEG stuff, yeah, well, that's whatever. Now in our, it's good. Okay, that, yeah, because that belongs to JPEG XS itself. And then what we'll have is, then we'll have payload stuff, and that's going to include, yeah, video spot, color spec. Let's get rid of that. We can get the length there, and then the code stream. This, I think we can actually, yeah. And we'll, yeah, not so sure about that yet. Because the code stream, yeah, this is only potentially part of the code stream, because it can be fragmented across multiple packetization units. So yeah, we'll get to that. So it'll be like, you know, part, you know, all of or part of, yeah, the, yeah, blah, blah, blah. So yeah, that's the real code stream there, which in our case is an actual real frame. So you grab a frame, you say, hey, split it across this many, you know, this many packets, sorry, this many bytes, your packetization unit, and then from there, you can throw it into a RTP packet. So we've got the payload header. So really, it's like the payload is going to be something like, it's going to be the header. and then there'll be one packetization unit. So P, oh, yeah. Let's just copy, yeah. Like that. And that eventually gets put into our RTP packet. So if we have a little, it would be the header, and then that's like an RTP header. We'd have the payload, which is an actual slice of bytes, but we'd get that from, we'd actually get that from this. So we turn that into bytes. And we already know how to do the payload header, and we almost know how to do that with the packetization unit, because we know how to, we know what this looks like in binary a little bit now. Not sure about that, but we'll get there. It's cool. Okay, very nice. Happy. Okay, cool. All right, let's do this. Okay, yep. So as always, thanks very much. It's been a short one, but it's been very, I think, pretty efficient. Thank God we found that video, basically. Yeah, if there's anything you want to see or any questions or, yeah, like just anything really, if you got any ideas, just send it to that email address. And yeah, that's it. So yeah, thank you and see you next time. Ciao.